You know, we spend our lives online. We're streaming, we're on calls, we're running entire businesses, and we just expect the network to work. But we almost never think about the actual physical stuff, the wires and fibers that makes it all happen. Today, we're going to pull back the curtain on that unseen backbone. Because let's be honest, how can something so vital also be so incredibly fragile?
Oh, we've all been there, right? That moment of just pure frustration. The Wi-Fi dies, the call freezes up, the whole office network just gives up. And what do? We restart the router, we blame the software. But what if the real problem is hiding in plain sight?
You're seeing that right, 50%. A report from CTech Solutions found that half of all network failures have nothing to do with fancy software or expensive hardware. Nope, the culprit is often the humble cable itself. And that tells you everything. If you want a network that doesn't quit on you, you have to start with a rock-solid physical foundation.
So let's totally reframe how we think about this. These cables aren't just some messy jumble to be hidden away. As a great guide from Vertiv puts it, they're the critical and frankly overlooked foundation of our entire digital world.
And lifelines is the perfect word. I mean, it is not an exaggeration. For any business or even just a serious home office, a failure in your cabling it's catastrophic. We're talking downtime, lost data, productivity just grinding to a halt. It really is like the circulatory system for your tech. If it fails, everything fails.
Okay, so if we're going to build this foundation, the first big decision is, what are we going to build it out of? And that really brings us to the two main choices in the world of network cabling. You've got your traditional copper wires, and you've got modern fiber optics.
This chart just lays out the whole story. Copper, your standard twisted pair cable, is cheap. It's great, but you're limited to about 100 meters, and it can get messed up by electrical interference. Then you have fiber. It's just insanely fast. Goes for huge distances and has zero interference. But yeah, it costs more. And look at that distance difference. Single-mode fiber can push a signal for over 40 kilometers. It's not even in the same league.
But here's where it gets really interesting. This quote from OFS Optics points out a common misconception. You'd think the expensive part of fiber is the cable itself, right? Wrong. The real cost is in the optics, those little transceiver modules that turn electricity into light and back again. And that's why multimode fiber, which uses cheaper optics, is often the smartest, most cost-effective choice for networks inside a single building or a data center.
And even if you stick with copper, they're not all created equal. The category you pick makes a huge difference. You know, for a basic home or office setup, Cat5e or Cat6 is probably all you need. But if you're building out a data center or a server room that's moving massive files around, you got to step up. You're looking at Cat6a or even Cat8 to get those insane 40 gigabit per second speeds.
Okay, so we've picked our cables. Now what? How do we plug everything in without creating a nightmare of tangled wires? Well, that's where these small but absolutely vital little components come in. Your connectors and your patch panels.
A fiber optic connector is pretty simple. It lets you plug and unplug your fiber cables. And that might not sound like a big deal, but compared to a permanent splice, it's a game changer. It means you can fix things, troubleshoot, or change your network around later without a major headache. Think of them as the universal adapters for your data.
And patch panels. This is where the real organization magic happens. Instead of running a cable from a jack in the wall all the way across the room to a switch, you run it to this central hub, the patch panel. As you'll see people saying on Reddit all the time, this one thing makes your life infinitely easier when it comes to maintenance or future upgrades. It literally turns chaos into clean, beautiful order.
All right, now for the fun part, actually putting this all together. This section is all about the real-world, practical art of installation. And more importantly, how you can avoid the dumb mistakes that cause that 50% failure rate we keep talking about. I love this quote from CTech because, come on, we've all seen this. The spaghetti monster cabinet. And it's not just ugly, it's a performance killer. It chokes off airflow so your gear overheats, it makes trying to fix or change anything an absolute nightmare, and it puts physical stress on the cables themselves. It's just bad news all around. And then there's this. This is the goal. Just look at how clean that is. This is what proper cable management looks like. Every cable is neatly routed, it's secured, it's labeled. A network like this,
isn't just reliable, it actually performs better because air can flow freely and keep all the equipment cool. It's beautiful.
So how do you get from that plate of spaghetti to this work of art? You follow the process, and it all starts with a plan. You map everything out, you measure carefully. Then you run your cables, you terminate them properly at the jacks in the patch panel, and then, and I cannot stress this enough, you test every single connection, and you label everything. Seriously, do not skip testing and labeling. You will regret it.
Okay, here are the golden rules, the absolute must-dos. Always cross your data and power cables at a 90-degree angle to avoid interference. Respect the bend radius. If you put a sharp kink in a fiber cable, you've just created a very expensive piece of trash. Always leave a service loop, just a little bit of slack for the future. Use soft Velcro ties, not plastic zip ties that can crush the cable. And, for the love of all that is holy, label both ends of every cable.
And here's the other side of that coin, the big don'ts. These are the classic mistakes that lead directly to failure. Don't run data cables parallel to power lines. Don't bundle them up so tight you crush them. Don't block airflow and let your equipment cook. Don't stretch a copper cable past its 100-meter limit. And the biggest one of all, don't get lazy and skip testing and labeling just to save 5 minutes. It will cost you hours down the road, guaranteed.
When you follow all these best practices, you move past just having a network that, well, that works. You start building something that's genuinely resilient. A system that's not only fast today, but is reliable and totally ready for whatever you throw at it tomorrow. A huge part of being future-proof is getting ready for more speed. 10 gigabit Ethernet, or 10 GBE, is fast becoming the new standard, especially for businesses. If you're moving big files around or using a lot of cloud apps, you need it. And to make it work, you absolutely need the right cabling, like Cat6a.
So what if you want to be faster and more reliable at the same time? Well, there's a really cool technique for that called link aggregation or lag. Think of it like this. You're turning a bunch of small pipes into one giant, super reliable pipeline. If one of the physical connections fails, no big deal. The data just keeps flowing through the others without missing a beat.
Now, if you want the ultimate in reliability, you're looking at two main approaches. Stacking is the simpler way. You just make a bunch of switches act like one single device. It's easy, but there's a catch. If you need to do an update, the whole stack has to go down. The pro-level move is VPC, or Virtual Port Channel. Here, two switches are linked, but they stay independent. That means you can take one down for maintenance, while the other keeps the entire network running with zero downtime.
And this is the whole point. When you put it all together, high-quality cables, careful installation, and smart redundant design, your network completely transforms. It stops being just a utility, like the water or the power. It becomes a real, genuine strategic asset that gives you a massive advantage. So, I'll leave you with this one last question to think about for your own setup. After all this, is your physical network just a tangled mess you've shoved behind a desk, a total afterthought? Or is it a well-planned, robust, and reliable foundation, something you can count on as one of your greatest strengths?